and it doesn't break, but if I'm not lucky, I'll be cleaning up the mess for the rest of the class, right? So ceramics are intrinsically brittle. Polymers and plastic are typically ductile. But then imagine I put it in the liquid nitrogen, the whole thing. It wouldn't matter if it's plastic, or if it's metal, or if it is ceramic. When I drop it, it's going to shatter. There are several ways to teach materials and engineering. So you would start from an application. And just like the beverage container, what is the set of properties that we're looking for? And typically there are mechanical properties, electrical, thermal, magnetic, optical, deteriorative. A cell phone. What's the case made from? Not on this one. Well, I'm not talking about this case, I'm talking about the actual phone. Yeah, I don't know why Apple would take a metal that they used to have, it used to be an aluminum case, right, and put a glass on the back so that when you drop it, it shatters. It's just, to me, it's not a practical design because you're going to drop your phone no matter what. But basically, you're looking at a set of properties. And then you take those lists of properties and you get the candidates. What is this bottle made from? Okay, and what's that plastic made from? Oil. And what's oil made from? And hydrocarbons came from?
Did you say stars?
That's a philosophical discussion, but okay. So, even for the plastic, it needs to be formed into this kind of shape. And how did that happen? Magic. Boom! Turned into that shape. By processing, there was a process to make that. Right? So all of the parts for your car, they need to fit together. Somebody had to make a drawing. You know, this microphone, 1, 2, 3, 4. This works? Yes. Make. I'm not going to mess with it, but looks cool. I went to the concert. Have you heard about Rammstein? Do you like that band? It was Till Lindemann. It was not Rammstein, so it's very different. Every time he finished, he would drop the mic on the floor. I can do that. We'll see how far I get destroying USF property, but you can do that. Okay. Let's talk about those properties. Mechanical. Why mechanical properties are important for us? What kind of functionality? Yeah? To see how they might fail, right? You don't want things to fail, right? We're not making stuff to fail. Well, sometimes we do if we're talking about something that's consumable, but I'm not talking about that. Typically, they intend for the stuff to last, or at least to perform its function, right? Electrical properties may be important. Why? Yeah? Okay. For a beverage container, are those properties important? Okay. What about thermal properties? Have you heard about this saying, he was born with a silver spoon in the mouth? Poor baby, because the mouth got burned all the time. Have you ever had a silver spoon in your hands? Have you ever used a silver spoon? The thermal conductivity of silver is very high compared to stainless steel. You put it in the hot boiling tea, you burn your hands. You put it in the baby's mouth, it's not a good idea. So thermal properties may be important. In Florida, the delta T, meaning the temperature outside versus inside, is what? Maximum. 25. So the thermal insulation is important, but not that much important if, like, compared to Chicago or Minneapolis or other parts of the country where it's minus 50. You know what I mean? Optical properties. Are they important? It depends on the application. For a beverage container, are they important? Well, they can be. If you put some beverage in a plastic that's transparent and this ends up in the sun on your dashboard, I don't know, maybe. Why there are different grades of glass for a beverage container? There's green glass, there's transparent glass, there's brown glass. Why? For that specific reason. Deteriorative. This is very important, the deteriorative stuff. Why? I don't know if you remember, but there used to be a flea market on Fletcher. Remember? There was a guy who was selling riding lawnmowers from Walmart, brand new. They used to retail at Walmart for over $1,000. They were brand new. He was selling them for $500 each. Why? Because they were that color. They were sitting in the parking lot in the garden section of Walmart, and they rusted in about a year. So Walmart just didn't want them anymore. They didn't sell them, and he was selling them $500 each. Nothing wrong with them, but brand new, but just the looks, you know. We live in the material world, and we come from dust, and we're going to go back to dust. There's no way around it. Unless artificial intelligence would be able to somehow to know. I don't know. Mechanical properties. Weight percent carbon. This is weight percent. We're going to talk about what weight percent, volume percent, all that. Carbon, 1%. The hardness goes from just over 100 to 300 by just adding 1% carbon to iron. To control the process, to control the structure, to control the properties. Please remember this. This is material science training. To control the process, to control the structure, to control the properties. Process is part of this. It's your cooking process affects the structure, which is not shown here. There's microstructure that you need to look under a microscope to see what changes are there. And the properties, well, in this case, the hardness. Electrical properties for copper. Pure copper has very good electrical conductivity. This is resistivity 10 to the minus 8 ohm meter. And this is temperature. This is pure copper. Pure copper is a very good conductor. This is why all of the wiring in this building and your house is made from copper. Also, for the high-speed train, which I wish the United States had, China has it. Other countries have. The train can go 300 miles an hour. How does it get power? It gets power from a copper cable. And there's a sliding contact. So, if you make it out of pure copper, it wouldn't work. So what do? We add alloying elements But what happens is electrical resistivity goes up. So it's conducting less electricity. There are more losses and whatnot. So you can see here that increasing temperature increases resistivity. Also increasing impurities is increasing resistivity. And also deformed copper. See, this is as is copper and 1 atomic percent nickel. This is deformed copper, 1% nickel. Deformation also increases resistivity. You can go to Costco, you can buy chicken for $5, Sam's Club, the same thing. Or you can buy yourself a chicken for $5 at Publix and you can boil it. You can put it on the grill. You can make many, many dishes. It's still chicken, all right? So we have copper, and then we added nickel. And then this alloy was forged or processed by some sort of a method. Thermal conductivity is a measure of material's ability to conduct heat. The heat is only conducted in the presence of a temperature gradient, right? So if there's no temperature gradient, there's no heat that's being conducted. Does anybody know how heat is conducted in a metal? By what process? What particles transform the heat in a metal in terms of the thermal conductivity? Did you take chemistry? Ask AI how heat is conducted in a metal and give me an answer. And you give me an answer. I want an answer. How is heat conducted in a metal? By what? What's conducting heat in a metal? And electrons. Okay, good. We'll talk about that as well. Thermal properties. Here are ceramic fibers. And the best insulator, do you know what the best insulator is? Vacuum. Vacuum is the best insulator. How can heat be transmitted? Atoms. And there are no atoms in vacuum. Through light. Conduction, convection, and radiation. Right? Nobody told you that? You go into the sun. How far is the sun? Do you feel it on your skin? Yeah, so you get energy from the sun by the process of radiation. And by the process of conduction, you can get the heat, right? But you need physical contact. And what about convection? What is that? It's transferred through the gas, right? So, there's gas coming out of my mouth that has a certain temperature, so that's convection. In Dresden, I brought USF students who are very lucky, and I was very lucky. I had those grants from the National Science Foundation to bring USF students to Italy, to Germany, to Poland, and to China. Maybe one more country, but maybe not. We had a lot of fun. In Germany, in Dresden, there's Hygiene Museum. There's such a thing as a hygiene museum. If you ever go to Dresden, go there. And there's this device like this, and there are instructions, so you're supposed to touch it. And I go like this, and I immediately pull my hand off because I just burned my hand. And what that device has, it has a spiral pipe that goes around. Two of them go like this. Thank you. And one of them has warm water, and another one has colder water. So the way we are measuring temperature, we don't have a sensor for absolute temperature. We measure the delta T, the difference. So on a certain piece of skin, okay, and then I forced myself to just put my hand on this device. I cannot tell you about this experience that I had. Because your brain is going nuts. Because part of your brain is thinking, oh shit, I just burned myself. And another one is thinking, oh shit, it's cold. And it's one of those moments in life that you should experience. If you ever want to conduct a lab, that's another one. At some point, I'm going to bring rubber bands, so we're going to do this experiment because your lip is also a very high sensitive temperature sensor. Bottom line is also, tell me what temperature materials start to glow. Ask your friend. What temperature? There's Gemini that's built into Google now. At what temperature does material start to glow? Give me an answer. Like, if you don't know, it's okay. You didn't fail the class. You have a friend that can help you.
977 degrees Fahrenheit.
And how much is that in Celsius?
925.
Okay. If you see something that's glowing, don't touch it. Because it's hot. All right? Now, with this material that has air, and a lot of it, and just the fibers, you could be at very high temperature on one end and not burn your hand on the other hand. You see this person? This is air gel. Is there lights? Where are the lights? Do we have lights? Oh, here. Is it better? You see that? He's touching it. Magnetic properties. Still have your hard drive? No? How big is your hard drive? Now, why is it called hard drive? Because it's hard? Discs that it reads off of, like physical disc that's spinning. This is media, and the media could be even the cassette tape, and it could be analog, or it could be digital. Here's magnetization versus magnetic field. This is iron, and this is 3% silicon added to iron. So if we add a little bit of silicon to iron, it becomes a better medium for recording magnetic information. The last cell phone you bought, did it come with a charger? No, so you have to use your old charger. I used to work for this company called Motorola. Have you heard about that company? Do you know what was the first commercial product that they made? You don't know? It's called battery eliminator. Back in the day, you had to buy batteries for most of your portable devices. Believe it or not, they had them back in the day. So battery eliminator was just a power supply that you put in the plug into the outlet, and you get DC power on the other end. And back in the day, it used to be a transformer. You know what a transformer is? What is a transformer? How does it do that? Yeah, what's the process called? Does anybody know? No. Transforming. It's called induction. And when I was a kid, and I learned that trick in physics. I would take a nail and take a copper wire and wind it, and take another wire and wind it on the same nail. And yes, I used to stick it into the outlet. That's why I became super powerful. But anyway, bottom line is that adding 3% silicon, 3% is not a lot, right? But it boosts, it doesn't show you the scale. Optical properties. Aluminum oxide. Chemical formula Al2O3. I'm gonna teach you something which is really cool. Aluminum is a metal. The chemical formula is Al. Alumina is a ceramic, and it's a compound of aluminum and oxygen. Al2O3. This is single crystal called sapphire. This is polycrystalline, it's opaque. And this one is porous, and it's not transparent. Chemically, exactly the same material. What's the difference between those three materials? Chemically, none. Does anybody have a pencil? You have a pencil? What's the core of the pencil? Graphite. And graphite is carbon. Does anybody have a diamond ring? Anybody? Yes. What is that? It's a diamond. What is it made from? Carbon. There's a big difference between that core of the pencil and that diamond that's diamond, right? And we'll talk about it. Looks good, right? You can get the spectrum. Deteriorative properties. You can see if this structure is placed in salt water, that's what's going to happen. There are going to be cracks. So unfortunately, everything deteriorates. And we're going to talk about, philosophically, the reasons why it happens. There's a reason things are dirty, and they want to get dirty, and they are getting dirty, and we're fighting it all our life, right? Because this surface here is going to get dusty. There's a reason for that. Okay, crack growth rate versus load. This is as received, this is heat treated. You can see that the crack is growing at a slower rate if this material was heat treated. What would be the process in this case? What is the process? Heat treatment. What are the properties? Crack growth rate. What is the structure? It doesn't tell you. So, if you want to publish a paper in material science, you have to address all three: to control the process, to control the structure, to control the properties. So the rest of the class is going to talk about that. I actually know a person, she's a nurse, she had a hip implant, was in a lot of pain, but my neighbor here has 2 knee implants, and the reason he did that, he was a postman all his life. Hey, wait a minute, Mr. Postman, get your knees replaced at Tampa General Hospital. He can play racquetball. He does play racquetball after those knee replacements. Technology allows our physical bodies to last longer than they used to be, right? It's all about quality of life, I can tell you. It's very important for a human to have mobility. 3 of my grandparents had this kind of fracture. And they did not have a hip implant. and the quality of life wasn't very good. But nowadays, it's replaceable. The first requirement, it has to be biocompatible. Have you ever had a sliver that you didn't take out? I mean, it's a tedious process. You have to have tweezers. What happened if you didn't take it out? You didn't have no experience? Inflammation and pus? And your body kind of like eventually rejects it? Whatever it is, like if it's superficial or surface sometimes, right? Imagine putting a chunk of metal inside the human body. What happens? All sorts of interesting things happen. So first, it has to be biocompatible. It has to be chemically inert. Metals are not chemically inert, so how can we fix that? Well, there has to be some sort of a coating. They have to be physically, mechanically strong to support the forces. You know, I'm not fracturing my hips. But if I fall, and the older I am, the more brittle the bones are. True story, I was 12 or 11, and the teacher didn't tell me what to do. You're supposed to do the flip, and I jump, and I see my hand here. I had a fracture here. And then this guru professor, who was extending people's limbs by breaking them and putting exoskeleton, he decides to take my hand and fix it. Instead of fixing it in a neutral position like this, he fixed it like that. And what happened after 2 weeks? This bone's moved, and my arm started to grow like this, crooked. So they had to put me under again and break it, and it's still okay, I guess. Sometimes when you're too smart, it actually hurts. Oh, there has to be lubricity, right? Why do people need to get their joints replaced? Do you know why? Why? Well, they wear cartilage. That's this natural layer. My body, he was playing rugby. He's from Akron, Ohio. 23, age 23, needs a knee replacement. He's in his 50s, my age. He still did not replace his knee because he just worked out, and he's like a really big guy. So he has the muscles holding all this stuff up. That's one way of doing it. And he's in a lot of pain. My other friend Marcus had this. He's a much younger guy in his early 40s. And they tell you now, right after the surgery, you're supposed to keep walking. The sizing was done incorrectly, so the femoral stem cracked his bone. He got into a lot of pain after that. I can tell you the problem with hip replacement is that the lifetime of a hip implant is less than the lifetime of a person. So if there's a hip replacement that happened once and it's made out of titanium, there's a very high chance that a person in their later age would have to go through this procedure again, which sucks. So if we can create a material or a system that is better than this, cobalt chrome moly. Cobalt is nasty, toxic material. Titanium, there's titanium lobby, because titanium nitride is much better. Nickel titanium, nitinol, is much better than titanium, but certain companies invested a lot of money in titanium. And so for different kind of parts of the artificial hip, there are different materials that are used. Okay. But Would you rather be able to walk? So that gives you the functionality. Yes, it may be toxic. Yes, you may have to take painkillers. Yes, you're not going to be a Superman. But if you are, Steve believes that his knee implants are better than his original knees. And he plays racquetball every other day. And he's a retired postman. Catches sharks every other day too. All right, so this is the reason why we need to understand materials, and we need to understand their properties that depend on the structure, which depends on how they have been processed. 3 classes of materials: metals, ceramics, polymers. Properties: mechanical, electrical, thermomagnetic, optical, deteriorative. And why? Because we need to have selection of the materials. Let's see how Notebook LM did. Let's start with, which one was first? And I would anticipate that maybe 10% of you would actually do this. But I'll show you how cool this is.
Have you ever stopped to think why your coffee mug is made of ceramic and not
Shoot. But you know what? It's okay. If you cannot hear, it's even better.
from the simplest spoon to the most complex spacecraft?
Um,
That's right in the face. We need a replacement. And this is where
So you get like 7 minutes of the bottom line.
determines its internal structure. And that
And so how can I get this? There's an HDMI cable here, right? Supposed to get the video somewhere in the settings. All right.
Anything. Why is mastering this knowledge so critical?
And that's our mission today. We want to unpack the absolute cornerstone relationship that governs every single
Can you
material.
even tell?
It's this constant cycle
This is
that
not
links
real human
processing,
speaking?
structure, and property.
Get those 3 and you get everything.
Exactly. If you
Exactly.
understand how those 3 connect,
So,
how we can manipulate a material's internal structure to get a specific behavior, you
we
pretty much
are
have the
having
blueprint
different
for how
modalities
our
for
entire
learning.
physical world is built.
Okay, so let's unpack the discipline.
Some of us are better
The sources are
listeners.
pretty clear that
Some
there
of
are 2
us
sides
are
to
better
this.
like watching.
2 sides of the same coin.
Everybody's
One side
good
you've
with
got
like
material
hands-on.
science. This is the really deep fundamental investigation.
The research.
Yeah, the research into how a material's internal structure connects to its external properties. And this is often where brand new materials get invented.
You should think of the material.
This is interactive, meaning that you can type a question here. Okay. What material has the highest elastic modulus? This information is not here. It gives you something. Look at that. 1200 GPA. So you still got an answer. Again, this class is not about AI. But look at the slides. What's that? There's a quiz.
Wait, I was thinking Chris right
All right. Are you ready to do the quiz? We'll do it together. Come on. Previous. Which statement describes? See, I can't see. And that's what's going to happen to people when they get older. Yeah, but then I don't know. Which statement best describes the primary focus of materials engineering as distinct from materials science? Oh, that's a deep one. Categorizing materials into classes like metals, polymers, and ceramics based on chemical composition. Creating useful products from known materials and refining the methods to process them. Developing entirely new materials with known properties from theoretical principles. Investigating the fundamental relationships between the atomic structure and the properties of materials. What's the difference between engineering and science? Yes? The application. Developing entirely new materials with known properties from theoretical principles. Are you sure? Okay. An engineer needs to select a material for a specific application. According to the described procedure, what is the first step they should take? Identify candidate classes materials. Specify the process and technique. Analyze structure, property, relationships of available materials. Determine the required properties for the application. Based on the provided graphs for steel, what is the relationship between the cooling rate for high temperature and the resulting hardness? I like this. Provided graphs. Do you see any provided graphs? I know. Hardness is only affected by the carbon content, not the cooling rate. A faster cooling rate results in a higher hardness. Cooling rate has no significant effect on the hardness of steel. The faster the cooling rate results in lower hardness. Yes? Which of the following material types is generally characterized by being hard and brittle and is compound of metallic and non-metallic elements? Very good. According to the data on copper's electrical resistivity, which of the following actions would decrease its resistivity? Decrease its resistivity. So it's going to be more conductive. Okay. The optical properties of aluminum oxide, alumina, are shown to be highly dependent on its structure. Which form of aluminum oxide is optically transparent? And why? Why? Single crystal? Okay. I'll have to tell you why at some point, which I will. A design of an artificial hip implant, different materials are used for different components. Which component is commonly made of polymers such as polyethylene? And why? Because you cannot just add the lubricant. How does adding zinc, see, I'm good. I didn't even read it. How does adding zinc to copper affect its thermal conductivity? It decreases the thermal conductivity because it's an impurity. Okay? Deteriorative properties describe how materials react to their environment. What processing technique can be used to reduce the rate of stress corrosion cracking in certain metal alloys? Which of this is not listed as one of the 6 main categories of material properties? Congratulations. Oh, which one did we get wrong? So here's a question. If you take a screenshot of a problem and paste it into the AI and it solves the problem for you, is that cheating?
Well, it's 50-50, depends on if you get it right or wrong.
What?
It's 50-50, depends on if they got the question right or wrong, despite a multiple choice. Because
Multiple
sometimes,
choice.
because it can't tell if it's right, correct answer or the wrong answer.
I can tell you guys, I can tell you this. Are cars dangerous? Of course they are. A lot of people get killed. Are you going to drive your car to USF tomorrow? Okay. So, this is such a powerful thing. I just cannot believe it. Is there intelligence? I don't think so. Because if they can take the human body and rotate it 180 degrees, what are you talking about? It's just a statistical model. But it works. And the more important thing, it can store a lot of information that a human can't. I can tell you that a typical PhD thesis, you would have about 200-300 references. And it takes years for you to read all that stuff and to extract the information and present it. Whereas it has all the information in there. Yes?
How do you make the songs? I was wondering how do you make a song for each?
See, it has nothing to do with material science, but I can tell you how I make the songs. My daughter turned 19, and there was this service called Track something Track. So you can pay like $100, and somebody would make, and this app and this thing would make a song for you. And you can choose the voice, and it gives you a preview. And if you have the software on your laptop that can capture it, then it's free. But the lyrics I had something to do with, because I said, my prompt was, I want to create lyrics for Suno, and actually wanted the song to be like melody, and then a rap, and then metal, and then rock, and then metal, and then heavy metal, and then thrash metal. That didn't happen, as you've seen, because it's very hard to do that. But once you have the lyrics, there's a website called Suno, and there's an app called Suno, and you can create your own song. And I'm not here. You go to the studio is what I've created. See, they want to sell me something. I guess if I go into studio, they still want to sell me something. I don't know why, but it used to be free. Materials of mechanics and materials.
Thinking like a measure of the truth, stiffness in the lattice from the metal to the spruce. Whose law holds steady till the yield point breaks the call. Plastic flow takes over like a slow and steady song.
You go in here and you put in the lyrics, and over here you put in the style. So don't film it.